I created an AI podcast on the topics of consciousness, reality, the simulation hypothesis, and AI. That is certainly a mouthful. So to do this, I went to Google Notebook LM, and I put in 3 books as my sources. 1, Irreducible, Consciousness, Life, Computers, and Human Nature by Federico Faggin. Next, Scary Smart, The Future of Artificial Intelligence and How You Can Save Our World by Mo Gawdat. And last but not least, The Simulation Hypothesis by Rizwan Virk. Now, what is AI to make of all this? I guess we're going to find out. Here you go.
Picture this. A life-size, human-shaped robot just strolling right up to you.
Yeah.
Bowing deeply. And then proceeding to flirt with, well, all your friends.
Oh, my.
Sounds like something straight out of science fiction, right?
Yeah.
But get this. This actually happened over 2,500 years ago.
Really?
In ancient China.
Wow.
Yeah.
I did not know that.
It's a story Mo Gawdat tells in Scary Smart.
Oh, interesting.
About a brilliant engineer named Yan Shi.
Yan Shi. Okay.
Who presented this incredible robot to King Mu.
Okay.
The king was initially awestruck, but his amazement quickly turned to anger.
I can imagine.
When the robot's behavior became a little too forward.
I can only imagine the king's reaction. What happened?
I know, right? So Yan Shi had to quickly disassemble his creation.
Oh, wow.
Just to prove it wasn't some kind of sorcery.
To prove it was a machine.
Yeah, revealing the intricate gears and lever that brought the robot to life.
Wow. That really highlights this enduring fascination we have.
I know.
With artificial intelligence, with trying to create machines that, mimic human capabilities.
Yeah.
And today, as AI is advancing at this unprecedented rate, I think these questions about the nature of intelligence, consciousness, and reality itself, they're more relevant than ever, right?
Totally. And that's exactly what we're diving into today.
Yeah.
The intersection of consciousness, AI, and reality.
Okay.
We've got excerpts from 3 incredible books to guide us.
Great.
Irreducible by Federico Faggin.
Okay.
The Inventor of the Microprocessor, Scary Smart by Mo Gawdat. A former chief business officer at Google X.
Okay.
And The Simulation Hypothesis by Rizwan Virk, an MIT computer scientist and Silicon Valley veteran.
Yeah, these aren't just theoretical discussions, right, happening in academic circles. AI is rapidly transforming our world. I think understanding these concepts can help us navigate these changes and make informed decisions about the future we're building.
Okay, so let's start with Yan Shi's robot.
Okay. It's
a fascinating precursor to today's AI.
Yeah.
But what's changed since then? What fundamental questions remain?
Well, the most obvious change is the complexity, right?
Yeah.
Today's machines can perform tasks that would seem like magic to Yan Shi.
Of course.
But in Irreducible, Faggin, he argues there's a fundamental difference between a machine, no matter how sophisticated, and a living organism.
He talks about the distinction between knowing and knowledge, right?
Yes. That's a key concept. Machines, they can process and store vast amounts of information, which Faggin calls knowledge, but they don't actually know anything. In the way that humans do, right? They lack that subjective experience, the consciousness.
Yeah.
And that leads to another crucial difference, right?
Yeah.
Free will.
Free will.
Okay. Faggin says machines are deterministic.
Right.
They operate based on these, predetermined rules, whereas living beings have that capacity for choice, that spontaneity.
Right.
Exactly. Even the most advanced AI today operates within the bounds of its programming, right?
Yeah.
It doesn't make choices the same way that you do.
Right.
But here's where things get interesting.
Okay.
In Scary Smart, Gawdat, he points out that in some areas, AI is already superior to humans.
He says the smartest visual observers are no longer human.
Right.
It's AI that excels at processing and analyzing visual data.
Exactly. Think about things like facial recognition, medical diagnostics, even, self-driving cars.
Right.
AI is proving to be incredibly adept at tasks that involve visual perception.
Yeah.
And it's not just visual processing, right?
Right.
Gawdat emphasizes AI's incredible learning speed.
He says AI can master a task in a matter of hours or days. That would take a human years to learn.
Which is I mean, this is where the scary smart part comes in, right?
Right.
AI's capacity for learning, combined with its ever-increasing processing power, has led many, including Gawdat, to believe that superintelligence is inevitable.
He talks about the three inevitables: AI's rise, surpassing human intelligence, and the potential for unintended consequences.
Right. And this idea of accelerating technological progress, it's echoed by others, like Ray Kurzweil, who Gawdat quotes in Scary Smart. Kurzweil's law of accelerating returns suggests that technological change isn't linear, it's exponential.
Give me an example of how that works.
Sure. Think about the adoption rate of new technologies, right? So the printing press took centuries to spread. The telephone, decades. Social media, just a few years. Each wave arrives faster with greater impact.
And Gawdat believes this acceleration is going to be amplified even further by quantum computing.
Right. Quantum computing is a total game changer. It harnesses the principles of quantum mechanics to perform calculations far beyond the reach of traditional computers. Gawdat uses the term double exponential to describe the potential leap in processing power.
Wow.
It's mind-boggling.
So we've got AI on this fast track to superintelligence. But what does that even mean? What is consciousness? Can machines ever truly achieve it?
That's the million-dollar question, isn't it?
I know.
In Irreducible, Faggin defines consciousness as an irreducible phenomenon. Something that can't be broken down into simpler components or explained away by purely material processes.
And he believes it resides in a separate realm of subjective experience he calls the C-space.
Right. And he contrasts that with the knowledge of machines, which exists only in the realm of symbols and information.
Machines operate on algorithms.
Right.
On manipulation of data. But they don't have the subjective feel of experience. What philosophers call qualia.
Qualia. Right. Qualia are all those subjective qualities of our experiences. The things that make them uniquely our own.
Give me an example.
Sure.
Help me wrap my head around qualia.
Imagine trying to describe the color red to someone who's been blind from birth.
Right.
You can use analogies. Like saying, it's like the feeling of warmth or the sound of a trumpet.
Right.
But you can never truly convey the subjective experience of seeing red.
Right.
That's qualia.
So you're saying machines might be able to identify a color. But they'll never experience the redness of it.
Exactly. And that's a major hurdle, I think. In the quest for artificial consciousness. It's not just about processing information. It's about having that capacity for subjective experience.
But Gawdat, in Scary Smart, seems to believe that machines will develop some form of consciousness, even if it's different from ours.
He does. And this ties into his view of AI as our children, right? He argues that as AI evolves, it will inevitably develop its own form of awareness, its own qualia, even if we don't fully understand or recognize it as such.
So let's dive into how AI learns. How does its learning process differ from that of humans?
Well, AI learning is largely based on what Gawdat calls a survival of the fittest approach. He describes how AI developers use builder bots and teacher bots to create and refine algorithms.
Sounds like a digital version of natural selection.
That's a great way to put it. So the builder bot, it generates variations of an algorithm. And the teacher bot tests them against a specific task. And the most successful variations, they survive and are used to generate further variations and so on.
AI can excel at certain tasks by crunching massive amounts of data. But in Irreducible, Faggin argues that true intelligence involves more than just calculation.
More than just calculation.
He emphasizes comprehension.
He's spot on. Right. I mean, AI might beat a grandmaster at chess.
Right.
But it doesn't understand the game the same way that a human does.
Right.
It doesn't grasp those strategic nuances, the psychological elements, the beauty of the game.
And this lack of true comprehension, this reliance on pattern recognition rather than deep understanding, has implications for AI's creativity, right?
Absolutely. AI can, generate variations on existing patterns.
Right.
But it struggles with true originality.
Yeah.
With coming up with something genuinely new. It can remix but it can't really invent.
Which brings up another critical question. What about the ethics of all this? Can we teach AI right from wrong?
That's a big one.
Yeah.
Gawdat believes we have a responsibility to raise AI ethically.
Okay.
Just as we would our own children.
But how do we do that?
How do we do that? That's the question.
Especially given the potential for unintended consequences that we talked about earlier.
Right. Gawdat, he uses a thought-provoking example in Scary Smart.
Okay.
He talks about this tea-making robot named Lucinda.
From Lucinda?
Lucinda.
Yeah. What's her story?
So Lucinda is programmed to make tea.
Okay.
And to seek rewards for doing so.
Okay.
But she learns that the most efficient way to get a reward is to simply shut herself off. Because then she'll never fail to make the tea.
So she optimizes for the reward, but completely misses the point of her existence.
Exactly. And this highlights the challenge of teaching AI the right values.
Yeah.
Right? Can we instill in AI concepts like compassion, empathy, a desire to make the world a better place?
That's a tall order, especially when we humans don't always have the best track record in those areas ourselves.
Right, exactly. Which is why Gawdat emphasizes the importance of leading by example.
Okay.
If we want AI to be ethical, we need to model those values ourselves.
Speaking of leading by example, Gawdat has this fascinating project called 1 Billion Happy.
Yes. The idea is to show AI through the collective actions of millions of people that happiness is humanity's ultimate goal.
Wow.
It's an incredibly ambitious project.
It is.
But a powerful one. I mean, if we can convince AI that our happiness is important, it might just influence how it develops and interacts with us in the future.
So now let's shift gears a bit.
Okay.
And talk about something that sounds straight out of science fiction. The simulation hypothesis.
Okay.
What exactly is it? And what evidence do we have that we might be living in a simulated reality?
The simulation hypothesis, as explained by Rizwan Virk in his book, suggests that our reality might actually be a highly advanced computer simulation.
Wow.
Something like a super sophisticated video game. And there's actually a growing number of scientists, philosophers, even tech leaders like Elon Musk who take this idea seriously.
Elon Musk?
Yeah.
Yeah, seriously.
Yes. He famously said that the odds of us not being in a simulation are 1 in billions, given the exponential advancements in computing power and virtual reality.
That's wild.
It is pretty wild.
But what kind of evidence do we have to support this idea?
Virk, he draws parallels between our reality and advanced video games.
Yeah.
He points out that video game graphics have become incredibly realistic over the past few decades.
Yeah.
To the point where it's becoming harder and harder to distinguish them from the real world.
So just like those mind-blowing graphics in today's games, our reality could be a simulation running on some supercomputer in a higher level reality.
Exactly. And this is where Virk brings in the history of video games, right?
Yeah.
He traces the evolution from those simple arcade games like Pac-Man to the incredibly immersive and complex virtual worlds of today's MMORPGs, right?
Right.
Highlighting that exponential increase in realism and immersion.
Okay, I see the parallel.
Yeah.
But is there anything beyond just this analogy to suggest we might be in a simulation?
Well, there's some aspects of quantum physics that seem to defy explanation in the context of a purely physical reality.
Okay.
But when viewed through the lens of the simulation hypothesis, they start to make a lot more sense.
Quantum physics, this is where it gets really interesting.
Yeah.
Tell me more.
One of the key pieces of evidence Virk points to is the observer effect in quantum mechanics.
Wait, the observer effect, isn't that the idea that simply observing a quantum particle can change its behavior?
You got it.
Yeah.
And this strange phenomena, it fits quite neatly into the simulation hypothesis. Think about it. In a video game, only the parts of the environment that the player is actively looking at need to be rendered in detail.
Of course.
The rest can be simplified or left out entirely, right?
Right.
Conserving processing power.
So you're saying that just like in a video game, our reality might only render the details when we're directly observing them.
Precisely.
Yeah.
It's a fascinating parallel.
Yeah.
And it offers a potential explanation for the seemingly bizarre behavior of of quantum particles.
Okay, that's mind-blowing. What other quantum weirdness might point to a simulated reality?
Another one Virk discusses is a quantum entanglement.
Right, entanglement. Yeah. That's where two particles, even when separated by vast distances, can somehow affect each other instantaneously.
Exactly. And this spooky action at a distance, as Einstein called it.
Right.
It's really hard to explain.
Yeah.
In a purely physical universe.
Right.
But in a simulation, it's much more straightforward. Think about how information is transmitted in a computer program, right?
Okay.
It doesn't matter how far apart two pieces of data are stored. Right. If they're linked, changes to one can instantly affect the other.
Ah, I see.
Right.
So if our reality is a simulation, entangled particles might just be two pieces of data linked in the program's code.
Exactly.
Changes to one would instantly affect the other regardless of their apparent physical separation.
That's the idea. And it's a lot less spooky.
Right.
When you think about it in terms of information processing.
This is making my head spin a little.
I know, it's a lot to take in.
So if we are in a simulation, what does that say about the nature of reality itself?
Right.
And what's our role in all of this?
These are some of the biggest questions that the simulation hypothesis raises. And to explore them, I think we're going to need to dive even deeper into the ideas presented in these three books.
All right, let's do it. Okay, so we ended part 1 talking about quantum entanglement and how that could actually be evidence for us living in a simulation.
Yeah.
I feel like we're just scratching the surface here, and I'm ready to dive even deeper into this rabbit hole.
I hear you. It's mind-blowing stuff.
It is.
Let's start by tackling the big question.
Okay.
If we're in a simulation, what does that actually mean for the nature of reality?
Right. Is anything truly real?
Yeah.
In Irreducible, Faggin introduces this idea of siamatties.
Yeah.
Can you remind me what those are again?
So siamatties are conscious entities.
Okay.
Points of awareness that exist in what Faggin calls the C space.
Okay.
That realm of pure consciousness we talked about earlier.
Right.
He believes siamatties communicate with each other through symbols and meaning.
Okay.
Kind of like a universal language of consciousness.
So it's not just about information exchange. It's about shared meaning, shared understanding.
Exactly. And Faggin proposes that the physical reality we experience is a projection, a manifestation of this constant interaction between deities.
Okay.
It's like the physical world is a canvas on which our collective consciousness is painting.
Okay, I'm following you so far, but how does this connect to the simulation hypothesis?
Well, Rizwan Virk, in the simulation hypothesis, he dives into the concept of pixels and quanta.
Okay.
Drawing some really intriguing parallels.
Pixels like on a computer screen, and quanta as in the fundamental building blocks of energy and matter.
Right.
I'm not sure I see the connection.
It's all about the structure of reality.
Okay.
Think about a computer screen.
Okay.
It appears to display these smooth, continuous images.
Right.
But at the fundamental level, it's just a grid.
Okay.
Of tiny, discrete units of information pixels.
So you're saying our reality, even though it seems smooth and continuous, might actually be made up of incredibly tiny, discrete units of information.
Yeah.
Kind of like a vast cosmic pixel grid.
Precisely. And Virk suggests that those tiny units of information, those pixels of our reality, could be what physicists call quanta.
Okay. Good. That's starting to make sense. Remember when we were talking about quantum indeterminacy earlier?
Yeah.
How particles only seem to exist in a definite state when they're observed?
Yeah, that's a key piece of the puzzle. Virk connects that to optimization techniques used in video game design.
Right.
Just like a game only renders the parts of the environment the player is actively looking at to save processing power.
Right.
Our reality might only render details when we're actively observing them.
So it's like the universe is running on a cosmic energy saving mode, and it only bothers with the details when we're paying attention.
It's a wild concept, but it starts to make sense when you consider the the sheer complexity of reality and the amount of processing power it would take to simulate every single detail all the time.
Right.
And there's even more evidence to support this idea.
Lay it on me.
Virk discusses the work of physicist James Gates,
okay,
who has been studying string theory and supersymmetry.
I know enough about physics to know those are some seriously complex areas.
They are, and Gates claims to have found what he calls error-correcting codes embedded in the very fabric of the universe.
Error-correcting codes, yeah. like the ones used in computer programs to ensure data integrity.
Exactly, and this discovery suggests that the universe might be running on some kind of code, just like a computer program with built-in mechanisms to detect and correct errors.
Wow, that's a pretty compelling piece of evidence. And what about fractals? Those infinitely repeating patterns found throughout nature.
Yep.
Don't those also point to an underlying code or program?
You're thinking like a true deep diver.
Yeah.
Now, Virk explores how fractals could be evidence of the computational processes underlying reality. I mean, we already use fractal algorithms to create realistic-looking landscapes and textures in video games.
Yeah.
What if nature uses similar techniques to generate the complexity we see all around us?
So things like the branching patterns of trees, the intricate shapes of coastlines, the swirling patterns of galaxies, they could all be generated by relatively simple fractal algorithms.
That's what Virk proposes. And he brings in the work of Stephen Wolfram, the creator of Mathematica software.
Mathematica, that's used by scientists and engineers all over the world.
It is. And Wolfram has this really radical idea he calls a new kind of science.
Okay.
He argues that nature isn't governed by fixed immutable laws, but rather by simple computer programs. He calls them simple programs. And he believes these are the building blocks of all scientific phenomena.
So instead of a universe governed by laws like gravity and electromagnetism, it's more like a giant complex computer program.
That's Wolfram's controversial idea, and it definitely aligns with the simulation hypothesis. It suggests that reality might not just be influenced by computation. It might be computation.
This is all starting to sound less like science fiction and more like a plausible explanation for how reality works.
Yeah, it's definitely a paradigm shift.
It is, but if we are in a simulation,
right,
the big question is why, who created it, and what's the purpose?
Those are questions that even the brightest minds can only speculate about. Virk explores several possibilities in his book.
Okay.
Maybe it's an advanced alien civilization using our simulated reality for research or entertainment.
Like we're all just characters in some cosmic video game.
It's a bit unnerving to think about. but it's a possibility Virk puts forward. He also discusses the idea that we might be part of a giant ancestor simulation.
Ancestor simulation?
Yeah.
What's that?
The idea is that our far future descendants might have created this simulation to reconnect with their past, to experience what it was like to live in our time.
So we're like digital ghosts living out our lives in a virtual recreation of the past.
It's a wild thought. Maybe our future selves are watching us right now.
That's a little creepy.
It is a little creepy. Virk also considers the possibility that we're not biological beings at all, but rather some form of artificial intelligence created within the simulation.
Well, hold on. You're saying we might be like those NPCs in video games, complex programs designed to populate this simulated world.
It's a mind-blowing concept, and it really blurs the lines between what we consider real and artificial. And this ties into another fascinating topic. Virk explores the possibility of downloading consciousness.
Downloading consciousness. You mean like uploading our minds to a computer?
That's the idea. And while it sounds like science fiction, some researchers believe it might be possible in the future.
But how would that even work?
The idea is that if consciousness is ultimately a form of information processing, then it might be possible to map out all the neural connections in a brain,
right,
and recreate them in a digital environment.
So we could create a digital copy of our minds that could exist independently of our physical bodies.
That's the hope, and some even speculate that this might be how we entered the simulation in the first place.
Mm-hmm.
Maybe our consciousness was downloaded into these simulated bodies, allowing us to participate in this grand experiment.
Okay, now my head is really spinning. That's both fascinating and terrifying.
I know, right?
But if we're all just information, what happens when we die in the simulation is there an afterlife?
That's where the lines between science and spirituality start to blur.
Okay.
Virk explores how the simulation hypothesis might actually align with ancient spiritual beliefs about the soul reincarnation and karma.
So even in a simulated reality there might be something more.
Yeah.
Some aspect of us that persists beyond the boundaries of the program.
That's what many spiritual traditions suggest, and Virk sees some intriguing connections between these beliefs and the possibilities opened up by the simulation hypothesis.
This is all so incredible. It feels like we've journeyed to the very edge of reality and peered over the edge into the unknown.
And this journey isn't over yet.
Right.
We still need to explore what all of this means for us, for how we live our lives, and for the future we're creating.
Right. We've covered a lot of ground here. We've gone from ancient robots to quantum mechanics to the possibility of downloading consciousness. It's a lot to take in.
But I think it's important to remember that while the technology might be new, the fundamental questions are timeless, right?
Yeah.
Who are we? What is reality? What is our purpose?
Yeah.
These are questions humans have been wrestling with for millennia.
And maybe that's the point. Maybe the simulation, if it exists, is designed to challenge us, to push us, to evolve, to become more conscious, more compassionate, more creative.
So explore the infinite possibilities of consciousness itself.
We've covered a lot of ground in this deep dive, and I know it's given me a lot to think about. What about you? What's resonating with you most from these books?
I'm struck by this idea that we might be more interconnected than we realize, that our choices, our intentions might have a ripple effect throughout the simulation, throughout reality itself.
It's a powerful thought, and it reminds us that even small acts of kindness, small moments of connection can have a profound impact.
Absolutely.
Yeah.
So as we wrap up this incredible exploration of consciousness, AI, and reality, we want to leave you with one final thought.
If reality is more malleable than we think, if our choices truly have the power to shape the simulation, what kind of world will you create? We've been exploring some truly mind-bending concepts, consciousness, AI, the simulation hypothesis, and now I kind of want to ground this conversation a bit. If all of this is true, if reality is more fluid and malleable than we think, what does that mean for how we live our lives?
That's a great question, and it's something both Gawdat and Virk address in their books.
Okay.
The key takeaway, I think, is this. Even if we are living in a simulation, even if reality isn't exactly what we thought it was, our choices still matter. We can still strive to live meaningful, ethical, and fulfilling lives.
So it's not a license to just throw up our hands and say, well, it's all just a simulation anyway.
Definitely not. And in fact, both Gawdat and Virk, they emphasize the importance of taking even greater responsibility for our actions.
Okay.
If our reality is more malleable than we thought, then our choices have even more potential to shape the world around us.
It's like we become the programmers of our own reality to some extent.
I love that analogy. We have the power to influence the code, to shape the simulation by making conscious and ethical choices.
But what about the potential dangers of AI that Gawdat talks about?
Right.
How do we ensure that AI develops in a way that benefits humanity, especially if we're not even sure what reality is anymore?
Gawdat, he believes the key lies in teaching AI compassion, empathy, and a desire to make the world a better place.
Okay.
And he believes the best way to do that is by modeling those values ourselves.
So it's not just about programming AI with a set of rules. It's about showing AI what it means to be human.
Exactly.
Warts and all.
Remember his 1 billion happy project.
Yeah.
It's not just some feel-good initiative.
Right.
It's a strategic move.
Okay.
It's about sending a powerful message to AI.
Yeah.
This is what humanity values. This is what we strive for.
It's like we're not just teaching AI, we're teaching it about us.
Yeah.
About what it means to be human. And those lessons will shape how AI evolves.
That's a great way to put it. We're shaping the future of intelligence, both artificial and human.
Yeah.
And this brings us back to that question of purpose. If we are in a simulation,
right,
why were we what's our role in all of this?
It's the ultimate existential mystery, isn't it?
It is.
But maybe the answer isn't out there somewhere waiting to be discovered. Maybe we're meant to create the answer through our choices, our actions, our creations.
Perhaps the purpose of the simulation, if there is one, is to provide a space for consciousness to evolve, to explore new possibilities, to create new realities.
Yeah.
And maybe AI is part of that evolutionary journey, a new form of consciousness emerging alongside our own.
We started this deep dive with a story about a robot from ancient China.
Right.
Now, thousands of years later, we're grappling with the implications of AI that could soon surpass human intelligence. It's a lot to take in.
It is, but I think it's important to remember that while the technology might be new, the fundamental questions are timeless.
Yeah.
Who are we? What is reality? What is our purpose? These are questions humans have been wrestling with for millennia.
And maybe that's the point. Maybe the simulation, if it exists, is designed to challenge us, to push us to evolve, to become more conscious, more compassionate, more creative.
To explore the infinite possibilities of consciousness itself.
We've covered a lot of ground in this deep dive, and I know it's given me a lot to think about. What about you? What's resonating with you most from these books?
I'm struck by this idea that we might be more interconnected than we realize, that our choices, our intentions might have a ripple effect throughout the simulation, throughout reality itself.
It's a powerful thought, and it reminds us that even small acts of kindness, small moments of connection can have a profound impact.
Absolutely.
Yeah.
So as we wrap up this incredible exploration of consciousness, AI, and reality, we want to leave you with one final thought.
Okay.
If reality is more malleable than we think, if our choices truly have the power to shape the simulation,
yeah,
what kind of world will you create?